I'm sorry for the delay on getting this out. I had a busy Wednesday with getting grades updated, and I had to take off to go to a track meet. So, um, so day late, but same information. So thanks for being patient. All right, today we're going to talk about conditions for triangle congruence. We're going to talk about the first one, which are AAS and ASA. You should know what those mean here in a minute. And then the next one, we'll go ahead and talk about the other remaining conditions for triangle congruence. So first thing we need to remember that congruent triangles, all corresponding angles are congruent, all corresponding sides are congruent. Conveniently, we don't always have to have all of that information. We don't need to have the three angles. We don't need to have the three side lengths. If we have some of the information, just based on the fact that they're rigid structures, we can kind of make logical inferences on what's actually happening after that. So yeah, let's talk about the first one. The first one we're going to talk about is ASA, or angle side angle. So if two pairs of corresponding angles have equal measure and the pair of sides between them have equal measure, then the triangles are congruent. So an example over here, we have a measure of 23. We have an angle measure of 23 degrees. Let me go ahead and highlight that in both triangles. And then we have a angle measure of 124 degrees in both triangles. And then we have a side length of 8.9 units. So we kind of talked about this when we were doing our modeling of, if you had class already this week, we talked a little bit of kind of exploring how this works using a model that's embedded into your CPM curriculum. So if you think about it though, if all of those are set lengths, okay, if you just think about this from a conceptual standpoint, if this angle were to change to be more than 23 degrees, right, it's going to impact the angle over here, 124 degrees, the angle over here, and it's also going to impact this side length there. So if they're fixed, like if this angle's fixed, that angle's fixed, the 124 degree angle fixed, and that's fixed as well as that side, that means in order for it to work, in order for it to be a triangle, right, these lengths here have to be exactly the same. If you change that angle at all, it's going to adjust other angles and other side lengths. With that being said, if they're fixed, it's going to work. It's always going to work where you have congruent triangles. If you haven't played with that model yet, it might not be as clear. But basically, if you change anything on one, it will drop that congruence condition. But if these are fixed, if they're not moving, right, they have to be the same proportionate size, which means they would indeed be congruent. So in this case, it's angle side angle. All right, that's one of them. So ASA is what's usually called. Okay, the next one isn't quite as clear. I think the angle side angle one makes sense. The angle side also is helpful. So if two pairs of corresponding angles and a pair of corresponding sides that are not between them have equal measure, then the triangles are congruent. So in this case, we have our two congruent angles here. We have 42 and then 42, and then we have 76 and 76, and then we have our congruent sides, equal sides of 15 and 15. Okay, so all right. So remember, these are fixed. They're not moving. They're the same. So a lot of students will be like, well, if I change this angle, yeah, well, if you change that angle, we're not making the angle side argument, right? They're different. They're not congruent. So the argument gets thrown out. We're talking about fixed shapes here. If you notice that this 15 is opposite of that 76 degree angle, and the 15 is opposite that 76 degree angle. So if we think about that, if this is set at 76 and this is set at 76, right, and we have a 15 there, right, and 15 there, it has to be the same for both of them. If this changes, right, that angle would have to change. Or if the 15 changes, this angle is going to have to change, impacting all the other angles. Henceforth, if it's fixed in place, it has to be proportionate. These sides have to be the same, right? They absolutely have to be the same length. If this side were to increase, then that would no longer be a 76 degree angle, right? If it decreases this way. If it decreases the other way, this would no longer be a 42 degree angle. It would decrease. So they have to be fixed in place. If you change one, right, it changes everything. But since they are fixed in place, the angle side will definitely work. All right. Let's play with some examples of this. All right, determine if the triangles are congruent, state how you know either way. All right, so remember, there's two other three-letter congruent situations we'll talk about in the next video, and we'll briefly talk about how we can use a right angle in the next one, a right triangle in the next one as well. For this one, we're going to focus on ASA and AAS. All right. So right here in this one, we have one congruent angle, and then we have another congruent angle. All right. So we know these angles are congruent because they are denoted or marked as such. The two lines here indicate congruence between these two angles. Let me change my highlighter color here. And this angle right here, these single lines indicate they're congruent. Now you're asking, well, what about the side, Mr. Robinson? Well, in this case, they share this side, right? So this side is the same. So in this case, we have angle, side, angle. So two congruent angles here, two congruent angles here, and a side that connects the two. So we have angle, side, angle in this scenario. All right, the next one. Okay, so we have, very clearly, we have the two right angles, right? Those are congruent. And then we have these two angles, which are acute. We don't know the specific angle, but we know they're congruent because they're marked as such. So we have this single curved line and single curved line on both sides, indicating that they are congruent angles. It also visually appears that they're the same angle, but that doesn't matter. It's really about how they're marked. And then once again, they're sharing a side. So this side is being shared between the two triangles, making it congruent as well. So once again, we have an angle, side, angle situation, ASA. And if we want to expand on that, we could say in both these scenarios that the angles are marked as such and they share a side. Okay, let's look at this one. So in this scenario, we have two sides. Two sides, it's good because remember, if a triangle, if we know all the sides of a triangle are the same, that's a good indicator that's probably going to be congruent. We'll talk about more on it later, but we don't know the third side. So we have one congruent side, second congruent side, right? With that being said, depending on the measure of this angle here, which we do not know, right? We do not know that angle measure. Actually, we don't know any of the angle measures. If we had any angle measure in here, we could say it. Seeing as we don't, let's just fixate on this angle right here. Let's say this is just for pretend time, let's say that that's a 95-degree angle and this one is a 97-degree angle. The smaller angle would result in a smaller, right? The smaller angle would result in a smaller side opposite of it. The larger angle would result in a larger side opposite of it. So since we don't know this angle, right? Since we don't know what that is, or really any angle in that, we can't make assumptions that these are congruent triangles. So we just don't have enough information to say it's congruent. So at this point, we're going to have to say not enough information. Not enough information. So you could say not congruent, but I like the word appears to not be congruent. I know you can make the argument that you don't have enough information, just don't call it congruent, but I think it's more appropriate to say, I don't know. And I don't think we often fixate on knowing and having the right answer all the time in life. Sometimes you don't know, and recognizing you don't know is perfectly fine. So not enough information appears to be not congruent. Okay, now if we had any other piece of information on that, right, literally any other piece of information on that triangle, we can make a definitive statement. But at this point, we can't. Okay, now let's look at this one. This one is probably the most confusing out of all of them. So we have the obvious angle here, right? So we have one angle. And then we do have, right, we do have a congruent side right there. Now, there isn't anything else that denotes that angles are congruent here. But if we go back and think about what we learned previously in math classes, so we have right here what we have are vertical angles. So these two on opposite sides are vertical angles. So vertical angles, if you remember, are congruent. So anytime we have an intersecting line, so boop, the angles opposite of each other, so in this case 1 and 2, right? Those are going to be the same angle. If you think about it, this line intersects, let's pretend I made a straight line there, intersects here, right? It's going to be intersecting the same angle regardless of the side of that line you're looking at. Therefore, those sides will indeed be congruent. So we can actually go ahead and rightfully make the assumption that these angles right here are also congruent. So and this is a case where we have an angle, angle, side, angle, side, right? So since we have the angle on the side, we can go ahead and say that this is an AAS. We can say marked congruent angle. Angle and side, and then vertical angles. All right. Okay, so later in math, you're going to learn the law of sines, which adds another tool in how you can determine sides and angles based on what you know. Right now, we're focused on just recognizing if it's an ASA or an AAS. For those of you who had class on Monday and Tuesday or this week and you've played with that tool a little bit, it will probably make a little bit more sense to you. Those who have not, after you've had class on Friday and we've played with the tool, and you can kind of see what happens with the triangles as we manipulate them proportionately, this should make a little more sense. All right, thanks for watching. Have a good one. Bye.